Welcome back to the King tutorial class. In this class, we'll be looking at using matrix to solve 3 by 3 simultaneous linear equations. Now, in this case, we're given this simultaneous linear equation to be what? 3x plus 4y minus z equals 3, x minus 3y plus 4z equals 1, and minus x minus 2y plus 5z equals 4. Now, to solve this simultaneous linear equation with matrix, what do? You have to represent inside what? The 3 by 3 what? Square matrix. Okay, so I'll go down it in this one, and then equals to what? Equals to this. Okay, such that I'll now start representing each of them inside the matrix. Now, for the first equation, we have that as 3, 4, minus 1. Second one, we have it as what? 1, minus 2, minus 3, 4. For the last row, we have that as minus 1, minus 2, and what? 5. Okay. So then we have this as what? X, Y, Z. And then finally we have this as what? 3, 1, 4. Now, I'm to look for what? I'm to solve for X, Y, and Z. Now to get Y and Z is using the idea of your what? Of your inverse matrix of your 3 by 3. So I have X, Y, Z to be equals to what? This is what? 3, 4, minus 1. 1 minus 3, 4. Minus 1, minus 2, 5. We have to multiply the inverse by what? By what? 3, 1, 4. Okay, so now how do we get the inverse as we treated in the last class? Is by what? Find your determinant and find your what? Your adjoint, which is your transpose of cofactor. So I'll be doing all those now and getting my, to get my inverse. After getting my inverse, then we'll now multiply. So we have x, y, z. Z to be equals to what? Okay, so we have minus 7, minus 18, 13. We have minus 9, 14, minus 13, and we'll now have minus 5, 2, minus 13. So that's 1 over determinant, which is what? The determinant there is minus 52. If you get your determinant from this matrix. So then this is transpose of the cofactor. The cofactor normally is what? 7 minus 9 minus 5 minus 18, 14, 2, and what? Minus 5, 2, 13, minus 13. So, but this is the transpose of the cofactor, which we have as this. So 1 over determinant times your transpose of cofactor is your what? Your inverse. So that's the inverse of this matrix times what? 3, 1, 4. Now, in which case, let's now multiply this by this before we now multiply by 1 over 52 to get our x, y, z. So x, y, z in this case now gives us what? This is t minus 1 over 52 into this times this becomes what? Minus 21 plus this times this gives us what? Minus 18 plus what? 13 times 4 gives us what? That should be 52, Abby. Okay, that's 52. So normal multiplication, that's this row times this column, this row times this column, this row times this column. So that's for that. Now for this second case, so we're going to have that what? Minus 9. So I'll be adding all this together. So this is plus 52. So minus 9 times 3, that's minus what? 27. Minus 14 times 1, that's what? 14. And minus 13 times 1 is what? Minus 13. Okay, so finally I have what? Minus 5 times 3, which is what? Minus 15. 2 times 3 there is what? Times 3 is 6. Plus, then minus 13 times 4 in this case. That's 2, carry 1. 4 times 1, 4 plus 2, that should be 6. 4 times 3, 12. Okay, that's 62. Now, finally I have that what? Minus 1 over 52 into minus 21 minus 18 gives us what? Minus 39. Minus 39 from 52. After solving, we're going to get this as well. Okay, so we have minus 1 over 52. We have minus 1 over 52 into what? 13. This is what? Minus 26 minus 61. This is 52. 13 times 4 is 52. Okay, so finally we have this as what? When we bring 52 inside, it becomes, this should be minus 1 over 4. Okay, because 13 in 52 is 4. We have this as what? This should be minus 1 over 2. Okay, then we have this as what? 61. Okay, there's minus here, so this becomes plus. So this is 61. That's be 61 over what? 52. So which invariably means that what? It means that my x is what? My x is the first one, which is minus 1 over 4. My y is the second one, which is what? Which is 1 over 2. And my z is what? 61 over what? Over 52. And that's how to what? So the basic idea is what? You should first arrange this your equation inside matrix rectangular form. And after arranging inside your matrix, then you will now do what? Find the inverse of this matrix. Then multiply the inverse by this your b, where we have general form as ax equals b. Okay? And our x is what? A inverse b, like that. So like that, and we are good to go. So that's how to use matrix to solve 3 by 3 simultaneous linear equation.